Okay, absolute value equations and inequalities. We'll start out with the absolute value of n plus 2 is equal to 5. You solve these the same way that you do regular algebra equations. It just has the absolute value notation in there. But what you want to do is isolate the absolute value before you can solve the equation. So let's isolate this by getting rid of the 2. That leaves us with the absolute value of n is equal to 3. Now, from your study of absolute value in the past, you know that the absolute value of negative 7 is equal to 7, and the absolute value of 7 is equal to 7. So you can have two values inside here, and they both represent the same number on the outside. So 3, what can be placed here for n that will yield a result of 3? You can put in negative 3, absolute value of negative 3 is 3, or you can put in 3, absolute value of 3 is equal to 3. So n is equal to negative 3 or 3. Okay, now let's do this one. This one's a little bit different because it's got the plus 2/3 in there. But what we're going to do is, because it can be a negative value or a positive value, is we rewrite the equation 2 times. So we go 2 is equal to m plus 2/3, and we write negative 2 is equal to m plus 2/3. So now we solve, just like normal, minus 2/3, that gives us 1 1/3 is equal to m, and over here we go minus 2/3, minus 2/3, and that gives us minus 2 2/3 is equal to m. So we have two answers. 1 1/3 is equal to m, and negative 2 2/3 is equal to m. Because whichever one we put up in this absolute value equation up here will yield an answer of 2. This time we've got a number on the outside of our absolute value grouping symbol here. So the first thing we have to do is isolate the absolute value itself. So we divide by 3, divide by 3. That gives us d minus 4 is equal to 4. So now we have isolated our absolute value. So we rewrite the equation. D minus 4 equals 4, and d minus 4 equals negative 4. And we solve plus 4 and plus 4, d equals 8, and plus 4 and plus 4, d equals 0. So whether we place an 8 up here, or if we place a 0 up here, we're going to come up with an answer of 12. A company makes a box of crackers that should weigh 213 grams. The quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for a box of crackers? Okay, it says any box that varies by more than 5 grams is sent back. That tells you a couple of things. It can be off by 5 grams because 5 grams is not more than 5 grams. So we can put a 5 here, and it says that it can be 5 grams. It says if it weighs more than 5 grams, it's sent back. That means it has to be less than in order to be kept. So it can be 5 grams or less. Okay? Now the question is, what is the range of allowable weights for a box of crackers? So we have to find out the variance. How do you find out how much something varies? How much does 2 vary from 3? Well, it varies by 1 because you go 3 minus 2 is equal to 1. So if we're going to find the variance in a box, we take what the box weighs. How much does a box weigh? Well, we know what it should weigh is 213. But what does each box actually weigh? Well, if you don't know, then you know that the value should be x. And when you're comparing how much the box weighs to how much it should weigh, you have to subtract 213 because 213 is what it should weigh. And this is an absolute value equation. and inequality, and so now we have to solve it. So we're going to do this. Let me move this down now. We rewrite our equation by going x minus 213 is less than or equal to 5. Then we rewrite it one more time, x minus 213 with a negative 5. But from your previous study of inequalities, whenever you are dealing with negatives, you flip the sign, the direction of the sign. So we're going to flip the direction of the sign and make it greater than or equal to. So now we come back over here and we solve. Plus 213, plus 213, x is less than or equal to 218. And over here, plus 213, plus 213, x is greater than or equal to 208. So our answer is x is greater than or equal to 208, and x is less than or equal to 218. The reason I write this for you like this is because if you see, you can just combine the x's and write 208 is less than or equal to, I should have the equal to there, x, which is less than or equal to 218. And that would be our answer. A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The allowable difference from the ideal weight is at most 0.05 ounces. Write and solve an absolute value inequality to find the range of allowable weights. So very similar to the last problem that we had. It's supposed to weigh 32 ounces, but it actually weighs X ounces. So what's the variance? You would go X minus 32, because this is how much the box weighs, this is how much it should weigh. So that's how we get the variance. We know that it can be positive or negative because it can't weigh 0.05 more than 0.05 more, and it can't weigh 0.05 less. So we put an absolute value symbol there. It says it has to be at most 0.05. So that means it can be 0.05, but it has to be at most. That means it cannot be more than 0.05. It has to be less than. So we put our less than symbol here, and our answer is 0.05. So now we come back over here and we rewrite it. X minus 32 is less than or equal to 0.05, and x minus 32 and negative 0.05. And remember, when we're dealing with a negative, we flip the direction of our inequality symbol. And so now we solve plus 32, and that gives us x is less than or equal to 32.05. Then plus 32 and plus 32, and that gives us x is greater than or equal to 31.95. And now we're going to write it in the correct notation. If you have this on your answer, you'll be acceptable. But to grow, you need to know how to write things in the better way. We take the 31.95, the smaller number. We put the x in the middle, and the 32.05, which is the bigger number, on the right. It says that x is less than or equal to 32.5. And x is greater than or equal to 31.95. X is greater than or equal to 31.95. And that's how you write your answer.